Hello students, good morning. My name is Dr. Basitti Mallikarjuna. I am working in Institute of Aeronautical Engineering in the Department of Information Technology. In the series of video lecture in the course of operating system, today I am going to discuss about the longest job first scheduling algorithm. So the scheduling algorithms we worked out shortest job first, first come first serve, round robin scheduling algorithms. But longest job first algorithm having its own features. Let me discuss. Longest job first scheduling algorithm is a operating system prioritized process with the longest burst time, meaning that process that will take most time to execute is given preference. It's a non-preemptive algorithm. So some of them are preemptive algorithms, some of them are non-preemptive algorithms. So once process starts, it runs to completion without interruption. So longest job first algorithm is different from first come first serve scheduling algorithm. So both are non-preemptive scheduling algorithms. But as for non-preemptive means it's voluntarily the process executed until completion of that process in the resource. It can remove and can submit the next process for the execution. The schedule process in the order they arrive without considering the priority of other factors. It cannot be stopped until it voluntarily relinquishes the CPU. So there are two types of schedulings completely: preemptive scheduling and non-preemptive scheduling. Preemptive scheduling is the operating system can interrupt or preempt running process to allocate the CPU, then it can switch more number of process to allocate it to the CPU. Context switching more in the preemptive scheduling process means that one process is select to the CPU, it executes sometime, the next process is select to the CPU. This is the term we are giving the preemptive processing. Means that its process is running to allocate CPU, the next process is given to submit to CPU for the execution. Round robin algorithm, shortest remaining time first algorithms, priority based on preemptive version or comes under preemptive scheduling algorithms. Let me check preemptive and non-preemptive in detail. Preemptive and non-preemptive. Non-preemptive means once process submit to CPU, it complete the execution completely. Then after completion of execution of that process, next process is going to be executed. That is non-preemptive. First come first serve scheduling comes under non-preemptive scheduling algorithm. So preemptive scheduling algorithms, it executes sometime and voluntarily remove from CPU and execute the next process. So non-preemptive, a running process cannot be interrupted by the operating system. It voluntarily relinquish and control of the CPU, and process holds CPU some time and give to the next process for the execution, because every process it give the time quantum or time slice in the non-preemptive scheduling. So that is a non-preemptive algorithm. So non-preemptive means first come first serve scheduling algorithm is a non-preemptive, and shortest job first is a non-preemptive scheduling algorithms. Okay, let me the execution of the one problem for the longest job first scheduling algorithm. See, longest job first scheduling algorithm. Hello students, here given the process numbers P1 to P5, their arrival times 0, 1, 2, 3, 4, their bus times are 3, 2, 4, 5, 6. Now, this process can works under the non-preemptive scheduling algorithm. So, longest job fast works with the non-preemptive scheduling algorithm. See, non-preemptive scheduling algorithms work with the longest process are executed fast. That is the principle we are following. See, longest burst time gets scheduled fast. Longest burst time. See here in the table, longest burst time 6. That is P5. That executed fast, but their arrival time is 4. So that is not executed fast. So first we will draw the Gantt chart. Let me draw the Gantt chart. At the 0th interval of time, so first which process will come? P1 will come. The arrival time is given. But P5 is the longest burst time, but the arrival time is 4. That is not executed fast. The arrival time 0. So burst time is 3. So first P1 process executed fast. It is a non-preemptive mode so that it executed completely process P1. Up to 3 units of time, it completes the execution P1. So of P1 is completely executed, then which process are coming into the ready queue? So P2 is in the ready queue. P3 is the arrival time 2, that also is in the ready queue. P4 is in arrival time 3, that is also in the ready queue. So up to 3, P2, P3, P4 are the ready queue. So which is the P2, P3, P4? Their bus times are 2, P3 bus time is 4, P4 bus time is 5. Which is the longest bus time? P4 has the longest burst time. So that will execute it fast. P4 has the longest burst time. So that will execute fast. P4. So up to 8 units of time, P4 is executed. Because their burst time is 5. So P4 is executed. Now 8. So now 8. So which process are arrived? P5 is also arrived in the queue. So now P3 is completed, P4 is completed, P1 is completed. So which is the longest burst time? So longest burst time has P5, that is 6. So P5 got the chance to execute the CPU. So P5 burst time is 6. So 8 plus 6. So 8 plus 6 up to 14. Up to 14 burst time P4 is executing 14. So P5 is completed. P5 is completed 6. P5 is completed. P4 is completed. P1 is completed. Now longest burst time is P3. Now P3 comes in the CPU for the execution. P3, that is 4. So 14 plus 4, 18. Up to 18th unit of time, P3 is also executed. So now 18, now only P2 is pending. So that is executed in the CPU. That up to now 20, all processes are completed. So now completion time. Now we draw the completion time. Completion time. P1 is completed at 3 units of time. P2 is completed at 20 units of time. P3 is completed at 18 units of time. P4 is completed at 8 units of time. P5 is completed at 14 units of time. So completion time will be done. Next, waiting time. Next, turnaround time. Completion time minus arrival time is a turnaround time. Completion time minus arrival time. 3 minus 0, 20 minus 1, 19, 18 minus 2, 16, 8 minus 3, 5, 14 minus 4, 10. Now I return the turnaround time. Now I am going to write the waiting time. Turnaround time minus burst time is a waiting time. Turnaround time minus burst time. 3 minus 3, 0, 19 minus 2, 17, 16 minus 4, 12, 5 minus 5, 0, 10 minus 6, 4. This is the waiting time. Now I am telling response time. Response time is having very important point to notice that when the process arrived in the Gantt chart is that time subtracted at arrival time. That is the response time. See, P1 is arrived at zeroth time in the CPU that's shown in the Gantt chart. P1 arrived zeroth time, and also arrival time is also 0. So 0 minus 0, 0, that is the response time for P1. So P2 arrived in CPU 18. Their arrival time is 1. So 18 minus 1, 17 is the response time for P2. P3 arrived at 14. So they arrived at 2. 14 minus 2 is the 12 is the response time for P3. P4 is arrival time 3 and their arrival time 3. 3 minus 3, 0. Their response time is 0. P5 arrived at in the Gantt chart 8. So their response time is their arrival time is 4. 8 minus 4 is the 4 is the response time for P5. Totally 33. Total 0 plus 17 plus 12 plus 0 plus 4 by total number of process 5. That is 33 by 5. So 6.666 we got their average response time. Average response time, that is they're asking average response time and average waiting time. So here in this problem we observed that here waiting time and response time both are same in this problem, because their arrival time 0, 1, 2, 3, 4, their response time also they arrived 0, 1, 2, 3, 4, that is the arrival time. We got the waiting times 0, 17, 12, 0, 4. Their response times also 0, 17, 12, 0, 4. Okay, we've seen the longest job first, but it is completely different. The process completely different than the shortest job first. Let me see the one example for shortest job first algorithm. So this is the problem, students. Now we given one problem. That problem, there are P1, P2, P3 process. Their arrival times are 0, 1, 2. Their bus times are 20, 1, 1. So this is a problem work with the shortest job first scheduling algorithm. So we worked out shortest job first scheduling algorithm under the non-preemptive mode. This problem works under the non-preemptive mode. So this problem we work with the non-preemptive mode. First, we will draw the Gantt chart for this problem. Gantt chart. At 0th arrival time, so process P1 enter to CPU and execute time, their bus time is 20 units of time. Up to 20 units of time, process P1 is executing the CPU. So in 20 units of time, P2, P3 also arrived in the CPU. So now P2 is arrived in the CPU and executed 1 unit of time, that is 21. And next P3 arrived in the CPU and executing 22 units of time, that is bus time is also 1. Now their completion times are, so P1 completed at 20 units of time, P2 completed at 21 units of time, P3 completed at 22 units of time. Now turnaround time, completion time minus arrival time. So 20 minus 0, 20, 21 minus 1, 20, 22 minus 1, 2, 20 turnaround time. Now waiting time, turnaround time minus burst time. Waiting time is, turnaround time is completion time minus arrival time. Waiting time is turnaround time minus burst time. 20 minus 20, 0. 20 minus 1, 19. 20 minus 1, 19. That is 0 plus total waiting time. 19 plus 0 plus 19 plus 19 by 3. That is equal to 38 by 3. That is equal to 16.33333. So that is the, we got the average waiting time. Okay. The same problem we worked out, we will change the arrival times. Okay, let's see the same problem we worked out once we change the arrival time. Let me check that process. Okay, students, the same problem, we change the arrival times. Now we worked out this problem. Once we can get the different answer to get the average waiting time for this problem. So same problem, we changed the arrival times. The same problem we worked out the under the shortest job first algorithm under non-preemptive mode. This problem can be starting to execute non-preemptive mode. First we draw the Gantt chart. So first at 0th interval of time, process P2 start executing in the CPU. At their burst time is 1. So up to 1, P2 is executing in the CPU. So up to 1 arrival time, P3 comes to the CPU and execute one more unit of time. Their burst time is 1, P3 burst time is 1. Up to 2 units of time, P3 is executing. Now arrival time is 2. Now arrival time is 2. P1 comes and execute 20 units of time. That is 22. P1 completed at burst time 22. Now we will calculate the completion times. P1 completed at 2 units of time. P2 completed at 0th interval of time. P3 is completed at 1 unit of time. Completion time. Turnaround time, we calculated completion time minus arrival time 0, 0, 0. Waiting time, turnaround time minus burst time. Waiting time. So we got turnaround times. All are 0. Waiting time, turnaround time minus burst time. That is 20, 0, 0. So we got waiting turnaround times, all process we got 0 plus 0 plus 0 by 3. The average waiting time is 0. So we will see the same problem under the shortest job first. We worked out, we got 16.33 here. We got the average waiting time. So the average turnaround time for the same problem, we got it 0. The same problem. Once we change the arrival times. So see, shortest job first is completely different in the longest job first algorithm. So longest job first, the longest job is executed fast. That is the most principle of the longest job first scheduling algorithm. So it is completely different than the shortest job first algorithm. So longest job first algorithm having best features and compared to shortest job first algorithm. So that's why longest job first algorithm was invented. So longest job first having that arrival time is when process enter into ready queue, that is arrival time. Burst time is the time a process needs to execute on the CPU. Completion time is when a process finishes its execution. Waiting time is the time process spends waiting in the ready queue. Turnaround time is the total time from arrival to completion. Response time is the delay before the process receive it first CPU. So these are discussed in the longest job for scheduling algorithm with the books I referred from Abraham Silverstadt, Peter Galvin, title of the book Operating Systems by Principle, Wiley Publishers, William Stalik's book title Operating Systems by Internal Design and Principles, Pearson Publisher. Okay students, in this video we learned completely about the longest job for scheduling algorithms with the examples, and we see the difference between shortest job first algorithms and longest job first algorithms in this video lecture. Thank you students. Thank you very much.